Welcome, students, and this is your first recording in Mr. Rogers' Neighborhood dealing with chemistry. And today is just going to be an introduction to what chemistry is and some of the scientific method, which I'm sure you've heard in other classes, and some of the basic terms that we'll be using as we go throughout the year, whether it be terms dealing with labs or values that we may use in science, just to familiarize yourself with these basic concepts. So let's move on. We're going to start kind of picking up from what we talked about on our first day. We talked a little bit about a biblical worldview as relates to science. And so we want to kind of define what a worldview is. It's the perspective from which you see and interpret life. And part of what I want you guys to understand is why would we talk about worldviews in a science class, or why would that matter one way or the other? Well, basically your worldview is your foundation for everything else. Everybody has a worldview of some sort or another, and that worldview is the basis on which you have your belief. And your belief, the core beliefs that you have, result in the actions, your attitudes towards this world, your actions, your day-to-day way in which you live your life, you treat people. And so we need to understand what our worldview is, because that will affect, when it comes to science, how we interpret things, what we believe about certain things. And obviously people have different beliefs, so they approach science in different ways. And when we deny that, then we don't really have a true understanding of what science is or how it operates. When we're doing science, what we're attempting to do is build a model. And your model is going to be shaped based off of your worldview. And a model is something that simply simplifies something in the world to try to explain it or describe it or represent it. Sometimes models are physical and we build something to represent something. Sometimes models are mathematical in nature. And we'll cover several different types of models as we go on throughout this year. One thing to understand about models is, and science in general, is science is not about establishing what is true. Okay, that's the realm of philosophy. Sometimes, if you want to say religion, you know, in a sense, obviously, we would say that the Bible establishes what is true. But science is not about establishing what is true. And sometimes people mistake that, and they take science as absolute truth because some scientist who has a PhD discovered something. Well, the reality is we've discovered all kinds of things throughout the years, and we found out years later that wasn't true, or it wasn't completely true. We had to modify something, and that's what the scientific method is all about. What science is really about is producing workable models. And in order for something to be a workable model or useful, a model has to work, and it has to predict what will happen. And we'll talk about this more when we get into the scientific method and the experimental approach. That idea of predicting what will happen is extremely important. One thing we want to understand as we begin here, when science contradicts the Bible, it's not nature contradicting the Bible. It's not like, well, we observe something out there in nature and it completely is contrary to what the Bible. Really what it is it's a scientist's model, and that model is created by his worldview that contradicts the Bible. So that's what we need to understand. Science will never contradict the Bible, and it never has. It's somebody's worldview that may contradict the Bible, and then they try to build a model off of that. And the reality is, the further that worldview is from the Bible, the more off we're going to be in terms of real true science. And there's going to be flaws in that scientific method. And we'll talk about some of those problems later on this year. All right, real quickly, we want to just, and this, I'm going to go fast, so you're going to have to keep your pens moving as you write in your notes. Just want to briefly introduce the history of chemistry. And again, there's a lot more names that are mentioned in your book. We're not going to cover everybody's names. That's not the important thing. We just want to have an understanding that history has gone back for a long period of time, and there's been a lot of different people that have been involved and cultures that have been involved in the development of chemistry. But let's establish what is chemistry to begin with. It's the study of matter and the observable changes in matter brought about with interactions with energy. basically, if you want to sum it up in a sense, and I don't put this on a test, but basically what we're studying are two main things this year: matter and energy. That's basically what you study when you study chemistry. We kind of define what is matter, how does matter interact, how does matter change, and then we'll study a lot with energy, and we'll keep track of energy and the release of energy as bonds are formed or bonds are broken, and how we can use that as we form new compounds and chemical reactions. And things like that. All right, the history of chemistry. Probably the earliest form of chemistry known to man would be what we call metallurgy. And metallurgy is quite simply the science of obtaining metals from their ores. And I don't know that this is necessarily in your notes. If you want to jot it off to the side, that'd be great. I think these next few definitions, I believe, are in your definition sheet that I gave you on the first day of class. And so and you see some of this. Matter of fact, we even have historically defined into ages. You have like the Stone Age, and then you have the Bronze Age, and then you have the Iron Age. Well, a lot of that goes down to that science of being able to obtain the metals from their ores. For a while, they weren't able to pull out or extract iron from its ore. When they were able to do that, we moved up in technology. Later on, we developed things like alloys, which is a solid solution of two or more metals. And they've been doing that for thousands and thousands of years now, that form of chemistry. We continue to look for alloys. When we send up a ship into space, it's not made out of iron, or even steel. We find, because of the tremendous stress that it's under, we have to find different alloys that will work better in space or under certain conditions. And so there's always, when we have jewelry is another example of an alloy. While gold looks nice and it's a very beautiful metal, you don't want something that's pure gold, and you won't find any rings, or necklaces or things like that are pure gold, because it's very malleable. And it would squish completely out of its shape, and so as a result, we alloy it with a stronger metal, so that has the strength of one metal and the beauty of gold. Okay, so those are just some early versions. We're going to continue to go fast here. If we fast forward to the Egyptians, of course, the Egyptians had a number of different advances dealing with chemicals. One was apothecaries, which are basically early pharmacists, and if you want to say drugstores in a manner of speaking. Of course, the Egyptians used a wide variety of chemicals and herbs for medicinal purposes. You guys are probably familiar with mummification as well. Even in the form of makeup as well, the early makeup, they were made some advances there. And then we get to the Greek influence on chemistry. Probably one of the biggest things, or the two biggest things that they did, one was they developed the concept of logical reasoning. And if you hear of some of the Greek philosophers and the idea of logical reasoning, that's what they gave us. They also believed that all things were composed of matter. Now, what they even broke it down into four basic. They understood that matter could be broken down into elements, and we'll talk about matter and elements in a later chapter, but they were the first to really figure that out. Now, they came up with the wrong elements, but we'll kind of talk about in class why they came up with the wrong elements. There was actually logic to it, and their four elements were earth, air, fire, and water. And we'll go over some examples in class as to why those particular elements. But they did have a grasp that, matter can be broken down into elements. And if you look at, we have the periodic table of elements. Why? Because matter can be broken down into those elements. All right, what about chemistry during the Middle Ages? The biggest advancements in the Middle Ages was alchemy. And most of what the alchemists did was hocus pocus. They thought they could turn basic metals into gold, like lead into gold, or rocks into gold, or things like that, or create love potions, or things that could grant eternal life. It was completely ridiculous. But they did give us a few key things. And here's what I want to point out here, and this you will definitely need to know. There's three key things that the alchemists gave us. One are laboratory techniques, such as distillation, filtering, or filtration, those kind of things. We'll do some of those techniques in class. Laboratory equipment, beakers and flasks and things like that. The experimental approach, which ultimately later on sparked the scientific revolution. So those three things were key in the history of chemistry. All right, in the modern era, we have a couple guys. I'm just going to show you. Robert Boyle developed the new definition of an element. Joseph Priestley and Antoine Lavoisier, they both worked on discovering the element oxygen, along with some other elements. Their work, and more specifically the experimental approach, led to a revolution in how chemistry was approached. Instead of just thinking through logically, the idea of experimentation was introduced, and that was important. Okay, so now that we come to modern chemistry, what is modern chemistry? There are several branches. We're going to focus on three of them this year. One is inorganic chemistry, and that's the one we will spend the majority of the year on. And it is the study of all elements other than carbon and their compounds. Then there's organic chemistry, which is the study of compounds containing carbon, and we'll have a section covering that at the end of the year. And then there's biochemistry, which is almost kind of a mix of the two. It's the study of chemical processes, specifically in living things, and that organic chemistry and biochemistry go along nicely together. Then there's nuclear chemistry, which is the study of the nucleus and the particles it emits. We might touch briefly on that. We won't emphasize that a whole lot. Then there's physical chemistry and analytical chemistry, both of which will touch on parts of those as we do labs and things like that throughout the year. Okay, so what is science in general? It's a systematic study of nature based on observations. That's what you do when you're doing science, is you're observing what goes on around you, and then usually you have questions, well, what about this or what about that? And there's two types of data that you gather through observation. One is quantitative data, which describes observations using numerical data. And that's important. Make sure you know the distinction between these two types of data. And we'll do a lot of this when we do labs, is we'll write down numerical observations. And then we'll compute something or calculate something based off of those numerical observations. So this could be recording the mass of something, or the length of something, or the density of something. Numerical values. Qualitative data are observations using non-numerical data. So this could be the smell of something, the color of something, the size of something is how that would be described there. So sometimes maybe in your lab they ask you to describe a change in color, or do you notice something in the appearance? Maybe there's bubbles, or maybe as you mix two chemicals together, it goes from one color to another, or it goes from a liquid state to a gaseous state, whatever it might be. That would be qualitative information. And then they use this information and they reason through to reach a conclusion. And we're going to briefly wrap up our time here with talking about the two types of reasoning. The first type of reasoning is this: deductive reasoning. And neither type of reasoning is better than the other. Deductive reasoning starts with general statements and works towards specifics. And this is usually your kind of logical syllogism. If you ever take a logic class, because point A is true and point B is true, therefore we lead to a conclusion. That's one way of approaching reasoning. Another way is what we call inductive reasoning, and this starts with specifics and works towards general conclusions. And we'll give some examples of each of these when you guys come back in classes next week. We'll briefly kind of touch on, so you're able to grasp a little bit more what deductive reasoning is and what inductive reasoning is. So that's where we'll kind of pick up. We're going to stop there. So you have an understanding of reasoning, and where we're going to lead into next is the scientific method. Basically, once you've gone through your reasoning process, how do we put that and use the scientific method to approach that? All right, I think that